All right, so the intersection of two rays at an endpoint. So starting from angle, so let's go ahead and go to angle. So we again covered other figures like lines and, well, mainly lines and line segments are what all these are here. So moving into angle, so angle is an intersection of two rays at an endpoint. So here I have a ray, so B to A and then on. So if I were to mark that, it would be BA with a line on top and the arrow in one direction from B to A. And then we have another line, ray, from B to C. So we got B to C. Now, putting them together, the easiest way to explain it is probably to use a scissors. This is usually what I use whenever I'm describing angles, because you're able to change it. So you can have a small angle. So here I have a small angle. If you look at if you imagine these parts being the rays, right? So there's a little spot right in here where it comes together. That's our angle. And I have a small angle, and as I open it wider, the angle gets larger and larger. And we can make it even larger, but, well, this one here is going to stop right about there, you know, probably about 120 degrees of opening. But again, as I open the scissor up, you can see that the angle gets wider and wider, and as I start closing it, it gets narrower and narrower until I no longer have an angle. But that's one way to easily describe it. And we also name angles using this thing here. Now, it might look like an inequality, so that's one of the things that, as they say, wants to eat the bigger number, you know, to show you which number is bigger. But this one here is not like that. The ones you're thinking of might have a much, it's kind of angled upwards, but with angles, the angle symbol, it's going to be kind of like 1 foot on the floor. So there's going to usually be a bottom side that's kind of flattish to the floor. And then this, we name it by any of the points that we have along that angle. So A, B, and C. So starting from A, go to B, and then to C. Now sometimes you have to label it like this because you might have a figure with multiple angles in it. So if you're ever confused, just go A, B, and then C. That's it. So A, B, and C. You could also say CBA, which would just be going back the other way, but typically we want to keep them in alphabetical order. I don't know, that's that's just the way it is. We just keep it in alphabetical order, not really caring whether it's going up, down, or moving to the right or anything like that. All right, next one here. So a vertex. So the common endpoint of an angle, so we still have that exact same angle in our figure, A, B, and C. And you can think of it as where the sides intersect. So I have one side here and then another side down here. So those are the rays, as we call them, because it doesn't continue on. Some of them will have a continuation, but this one doesn't. And the vertex, if you remember where that scissor was, that's where I point out where the angle was. So right there would be your vertex. So that's where it turns, basically, is what vertex kind of means, like a turning point where something reverses direction. And that's what's going on here. So it's, if you imagine it coming from one side, it kind of hits here and then it changes direction to a different side. So again, that's your vertex. And then next one here, we have right angle. So this one's pretty common. I think most people would know what it is. I think like some junior high students might know what it is too. So right angle is an angle with a degree measure of 90 degrees. So it's kind of like that notepad I showed you earlier, right? So most papers and most objects that we have are 90 degrees. You know, your computer screen is probably 90 degrees as well. And it's also marked with that little box here that shows that it is a 90-degree angle. Now, with that little box, you know, if it's an 89 degree or a 91 degree angle, no, that little box isn't going to go there. It's only if it's exactly 90 degrees. So that's how you know if it's a 90-degree angle. Acute angle, and I'm pretty sure you might have heard this one before too, because like it kind of sounds like cute when something is small. So that would be an angle that is less than 90 degrees. So anything that is less than 90 degrees would be an acute angle. So if I had, well, in this example, they give us an angle that is 50 degrees, but like I said, if it's 89 degrees or less, then it would be an acute angle. But this one's already telling us it's 50 degrees, so that's what they, that we kind of already know what it should be. So acute, again, that's pretty easy to remember. Obtuse, well, I don't know where you would find the word obtuse outside of math. Maybe I could do a Google search of what else would be obtuse, but I'm pretty sure I'm gonna get a whole bunch of stuff. Annoyingly insensitive or slow to understand. Difficult to understand. Non-sharp or blunted end. All right, number 2 is exactly what we're looking at. But I don't really, I mean, I know it's a word, but I don't really know. I don't really know exactly what it is. It just says slow to understand, I guess is the thing. But I don't know, maybe you could think of it like a cartoon character. Like usually in old Disney movies and Looney Tunes or something, there's usually like a big guy and he's always like not very bright. So I guess that's kind of where I guess you could kind of, I mean, think about it. So like an obtuse is something that's kind of like a big guy, but it really kind of means like slow to understand or something. But either way, I guess it's just to help you. But as long as you know it's the opposite of acute, and most people would know what acute is, you know, you wouldn't have any problem really figuring that out. Straight angle. Okay, so straight angle. Now my scissor only opened to about 120 degrees, if you remember. So one thing you could think about, and you know what, I don't know if I even have one, but you might have to think a little bit further back. If you can remember being in like kindergarten or first grade, they had those little metal scissors. They kind of look like this hole punch. The grips, you know, the whole thing was all metal and they had the big metal loops that you put your fingers through. Those ones, you could open them all the way so that way the blades would kind of form a straight line. And that's kind of what's happening here. So we have our vertex R, and it's open so wide that basically you do have the blades lining up in a straight line. So they line into a straight, they form a straight line. Now, sometimes I know sometimes people might look at this and say, well, isn't that just a line with 3 collinear points? And in a way it is, but again, if you can imagine some scissors that would do that, or if you look at a clock, you know, the hands on a clock move around the whole face. Something like 6 o'clock, you would have a straight angle at 6 o'clock. Now, I don't know if it would work at like, say, 3:15 or 9:15. Probably not. It would be slightly off because they don't always line up. But I know 6 o'clock would line up perfectly, though, into a straight angle because you got one hand pointing towards the 12 and the other one pointing toward the 6. And it moves around. But again, it's not necessarily a line because if you look at this diagram, it does look like a line. But that's what it is, 180 degrees. Like when people say, I turned my life around and made a 360 degree. All right, 360 is all the way around. 180 is all the way around. So a lot of times people confuse that one too. They'll confuse 180 with 360. Anyway, congruent angles. So next one here. So congruent angles have the same measurement. So just like we had congruent lines or congruent line segments. So in congruent line segments, you had 2, well, like if I had another string exactly this long, you know, if I had another string that was exactly this long, they would be congruent. And in this diagram here, I have angle A, which is 43 degrees, and then I have angle B, which is also 43 degrees. Now, to write it, we would say the measure of angle A is equal to the measure of angle B. Now, one thing you're going to kind of notice between these two ways, so this is one way of saying it, and this bottom one here is a different way of saying it. So we have this weird equal with a squiggly line on top of it. So when you see that equal sign with the squiggly line, that means congruent. So you're probably thinking to yourself, wait, doesn't congruent mean equal? And the answer is kind of yes, but also no. Now, I mentioned earlier that it's kind of like your buddy or somebody you know who is the exact same height as you are. Or maybe you have somebody who has the same shoe size or something like that. Right? So sometimes we have two things that are the same size, but they're not exactly the same thing. So again, with you and somebody you know who might be the exact same height, yeah, your height is the same, but there's a lot of things that are different about you. So, and maybe you have a twin or something, but even then your twin is not exactly the same person you are, if you did have a twin. So that's why we say congruent, because again, angle A and angle B are not the same. So, because we're not talking about the same angle, this is a person and that's a person and they're not the same person, but we can say they're the same age or they're the same height or they're the same something. You know, they would have some kind of measurement that is congruent, but they're not exactly the same person. But why does this one have an equal? You might be asking, how come that top one uses an equal? Well, because it's talking about the measure of angle A and the measure of angle B. So when the M tells us exactly that it's talking about the measure of it. All right, kind of a little bit off, I know, but maybe it went on a little bit longer than it should, but that's one thing to watch out. Again, is congruent and equal don't always mean the same thing. All right, so let's move on to the next one, and that would be adjacent angles. So an adjacent angle is, well, in this case, angles. Well, you can have an adjacent angle, but you already got to, anyway, two angles that share a common side and vertex. In other words, they are next to each other is another word that people would use to describe it, is next to each other. One example of that is behind me is Mr. Moreau's classroom. If you remember my classroom, or I don't know if you've ever been here, maybe you've never been here, but I have another teacher on this side, Mr. Moreau. And then on the other wall, on that side, I have Ms. Hanyoidi, Mrs. Hanyoidi. And we have adjacent classrooms. That means our classrooms are next to each other. Not only that, but we also share a wall. So it's kind of the same way with angles as well. You share the wall, share the side and all that stuff. And anyway, so here we have 1 and 2. So angle 1, angle 2. Now, in this case, they named them with numbers and not letters like they normally do, like A and B. So in this case, they named them angle 1, angle 2, because there's no points on there that we can use to name these. So that's another way you can name an angle, is either name it by its vertex or name it by points along that angle. Now, this kind of brings me back to that pizza example. If you remember, we had two pizzas that we cut. And one of them was cut in a way so that one side was way bigger than the other side. So we have that thing, that process in which we would use to cut two pizzas, and that was to have one person cut it and the other person gets to choose which one they want. This way it favors, you know, an equal size for each person. So if you can cut it right down the middle, one side is not really going to be that much larger than the other one, so they would be very much equal to each other. Oh wait, sorry. I was thinking of bisector. Okay. Adjacent angle just means next to each other, sorry. Angle addition postulate. So you might remember we had one that said the line segment addition postulate as well. And again, postulate just means it's a rule. It's a rule that we just sort of follow, right? Postulate means like something keeps happening and it comes out the same way, and the same thing keeps happening, and it pretty much always has to come out that way. So again, it's like a rule, but I don't know if these rules can be broken. So maybe a postulate is like an unbreakable rule or something like that. But anyway, postulate rule means the same thing. Now here it names these angles by their points, A, B, and D. So when it does that, A, B, D, you follow those lines like this. So here we're talking about what I'm going to call the upper angle. So I have an upper angle and then DBC. So from DBC, we have this part here, which is like a lower angle. Now, in this case here, they are adjacent. And if we were to take the angle ABD and add it to the angle DBC, so again, upper angle, add that to the lower angle, you would have another angle ABC, which following the points A, B, C. So in other words, if I add the two smaller angles that make up this larger angle, it's going to equal to the same measure as the largest angle in this set here. So that's the way that's another way we would write it, is something like that. Now, okay, so this is the one I kind of messed up on. And that is, you got to divide it into equal parts. And again, that's like the pizza example that I was almost mentioning. So again, you want to cut those pizzas in the exact same size so that neither one of them is really that much bigger or smaller than the other. Now, if you manage to cut them, here you're looking at the angle that made up both of those pizzas. So like if you imagine a huge pizza slice here and you cut it from this part to the end, to the crust part, you would get two equally sized pizzas if you were able to get the angle just right to get it right through the middle of both of those. And again, bisector just means cut in two. And bisector usually means to cut it into equal parts as well. So line array that divides an angle into two equal parts. All right, so next one here we have is vertical angle. So a vertical angle, that means there are two angles that are exactly across from each other, so directly across from each other. Now, if you have that, those lines are always going to be congruent. Okay, so congruent lines, like in this case here, angle 1 and angle 2, they're on opposite sides, right? They're both like on the side to side of each other. Measure of angle 1, measure of angle 2, those would be the same size, whatever it is. Now, this is not a really good example because it looks like they're all kind of the same. I don't know if I can, maybe I'm going to make my own line here. But in this case here, again, it makes it look like they're all the exact same size. But let's say I were going to do something like this, something a little bit different. Now, I have two straight lines, and you can tell that this part here is different from this one and this one. So the adjacent angles are not the same. And I'll go ahead and call this one here angle A. I don't know if I can call it that. And then here I would have angle C. So angle A and C would be the same size. And you can kind of tell just by looking at it, they're both kind of larger angles. So again, A and C would be equal to each other. And if I were to have two other angles, like if I were to have B and D, those two across from each other would be congruent. They would both be the same size angle, and that would make them vertical angles. So again, this one's a little bit of a better way of explaining it because the diagram they give you, you know, it does look like angle 1 and angle 3 could be the same size, and they could all be the same size. So that's why I made that example that's a little bit easier to follow. And I made them obviously different. And you can tell like two of them in pairs, they come in pairs that would match. And I guess speaking of that as well, one of these other ones comes up too. So complementary angles. So angles that have a sum of degrees that measure to 90 degrees. Now, in this case here, it points out that they don't have to be adjacent. They don't have to be adjacent. So in this case, they are adjacent. They are right next to each other. Like if I had a square piece of paper, right, and I just decided to cut it, I could cut it in a way that I would form two other angles, right? So like I could cut it here, cut it there, but no matter where I cut it in from this corner here, it's always going to be 90 degrees if I put those pieces back together. Now, looking at complementary, now I'm going to go ahead and do what I did earlier with the obtuse angle. Oh, what the heck? Complementary angles. But I'm going to see what complementary means just regularly. When things are different from each other but make a good combination, that's a good way to explain it. So things that go good together. So that's what it says, things that go good together or bring about in such a way that make a good combination. So like here, if I were to look at, well, none of these are going to work out. But here I have 55 and a 35. So if I found two angles just laying around and one was a 55 and one was a 35, and I managed to put them together, I would have a square angle. And I guess squares are pretty nice, right? They do add something nice that work in a good combination. And then you have supplementary angles, which again, I'm going to go ahead and look up the definition of that. But I'm going to take off the word angle and see what it gives us. So the definition of supplemental. Okay, so enhancing or completing something. This next one doesn't really seem to have anything to do with it. It just means adding more. But supplementary means to complete something. So completing something, oopsie, wrong one. So completing something. So in this case here, let's look at this 120 degree angle. And then I have another angle that's 60 now. Here it says it does not have to be adjacent. These ones are not adjacent at all. They're not sharing a side, right? They're not next to each other. So if I imagine a big pizza slice that's 120 degrees, and then I imagine another one that's 60 degrees, and I would take that angle that's 60 degrees and I would turn it so that it's facing a different direction. So I would turn it so that maybe it could fit right here, or better yet, I could fit it right here. You notice that there's a little space right there. Now, if I fit it in there, just like the definition said, it would complete it. We would have a complete straight edge. So that's kind of what it means by supplementary and complementary, is that one supplementary means it completes it, and complementary just means it goes nice with it, which again, in this case means it's a 90 degree. So be careful, because those two are also ones that get confused with each other. And trust me, it's actually something that I've done a few times. You know, I'll just put complementary or supplementary when I meant to say the other one. But yeah, just try your best to remember those. And then we also have a linear pair here. So adjacent angles that are supplementary. So putting them together, they combine to form a straight line. So again, like what I was describing here, taking this little piece, moving it so that it fits right into here. When it fits into that nice little spot, then that would make it straight, a linear pair. They would form a straight line in that case. And that's what it means by completing them. Now, if you were to take those and put them together so it would look like this, okay, so I know the degrees are a little bit off. You know, 110 is kind of close to 120, but they're not exactly the same thing. But putting them together means you get a straight angle, a straight line. Okay, so that, again, they fit together like a puzzle piece. So linear pairs can be supplementary, but supplementaries don't have to form linear pairs. All right, so I think we're done with that one. There's another part here, and I have my packet next to me here, but let me just go ahead and kind of zoom ahead to show you what we're going to be working on next. So we're going to complete this part. This is actually the first part. I call this the in-class work. So with most assignments, there's two parts. There's the in-class work, and that's what we do, well, in class. And those are the parts that we cover all together. Then there's a second part, which is the homework. So we're going to fill this out to here, and then the homework is marked homework. In this case, homework 1. points, lines, and planes. And in this case, it's only 3 questions long. It's only 3 questions long, so it's not going to be that much. And now, normally, during the normal school year, I would ask that the homework, you try that on your own. But I might come up with a system of getting help or something so that we could use it. So I might use that independent learning time, or if we have any other Zoom link time that is not used for lessons, we could probably go over some of the homeworks in the future. But like I said, I'm going to see how the summer goes, and we'll change things around, and just be prepared for, a lot of things. Be prepared to, have a tutoring session or something, and we'll go over some of the homeworks in those sessions. All right, so let's go ahead and answer some questions about some of these things. Now, that first part was just like a definition. And like I said, I hope you also write those down somewhere else in your notes and keep those, because you're going to be needing those probably for the rest of the course, which is not that long. This whole thing is only like 16 days. Okay, we only have 16 lessons, or sorry, 16 days of lessons. Some of these are pretty long. But 16 days is not really all that much. 16, yeah, it's gonna be just here and gone in no time. And that's going to go up until July 1st. So anyway, let's go ahead and get started here. I'll probably mention a few other things near the end of the class. But actually, you know what? There's kind of one thing else I also want to make sure to. With my first hour, and actually this is a problem I had in the spring semester, was that a lot of students, I don't believe they were attending the Zooms. Like, I don't know if there's a word for it, like ghost Zoom, or I don't know, absentee Zooming. But I had a problem of some students I think what they would do is log on, and then they'd walk away from their computer and go do other things, play video games or whatever, and just ignore the Zoom. If that becomes a problem, I know some schools will make you turn your camera on, but I was thinking of some other things too, like have you type a letter in the chat. But I'm gonna try to be a little bit fair and see if it works out okay. Because my first hour, even today, I had some students that I was asking them for their email so I could send them the YouTube channel link and stuff like that. I might give you a word to write down, and it might show up here and there. It might show up on a slide or something. So an example I just sent you one in the chat would be something like that. So you would see a word and you would just retype it somewhere else, like in the chat, and that tells me that you're still at your computer, you're still listening, and it'll be an easy word to spell, something that maybe a 3rd grader could spell. But that's just something I thought of, just to make sure you guys are actually listening. Yeah, that one works too. Or, I could probably do other things like a survey or something, who knows. But anyway, yeah, I'm just checking to see if you're still listening, because I know these lessons are long. I know it's summertime and, you probably want to go be doing something else, but we'll see. Anyway, so back to the lesson. I'm going to go ahead and start now. So point. So hopefully you were writing some of these down as I was talking, so that way we can go through it a little bit faster anyway. So point is, marks a location, right? So like thinking of a map, if you have a map, you can point to where something is, whether it's a store or somebody's house. Generally, you can kind of like point it out to somebody if they were looking for it, like if someone pointed on a map and asked you where is, I'm trying to think of something in town that would be kind of, it's not easy to find, but it's not hard to find. I don't know. One area I usually had to point out was the alternative school that's over by the bus yard. People had no idea where it is, but if they had a map, I could just show them where it was. I could just like point it where the road kind of branches off from the road that goes north or something like that. But anyway, yeah, that's what a point is. It's just marking out a location. Remember that it has no size and it has no shape. So they're not stars or rectangles or anything like that. And they're only circles because it's the only way to really mark something that doesn't have a shape, because it's like the lowest shape. And we use a capital letter to mark a point. So in this case here, they have a diagram with point A. So point A is right there. It's just really simple. And then we have a line. So a line is made up of points. And you would need 2 points to form a line. Any 2 points can form a line. A line has no thickness or width. So just like I was showing you earlier, we can zoom in on this line. It's not really gonna fix anything. I'm gonna get this out of the way. I think we're done with that. But yeah, so that line's not getting any thicker because its shape is indefinite, which again just means undefined, or we don't really know sometimes. Sometimes it can mean we don't know, but indefinite usually means like we don't know. But it could also be something we can't measure either. Anyway, name a line by any 2 points on that line or by a lowercase letter. So here I can call this line XY, and we would mark it like this, XY with the line on top and the little arrowheads to point that it goes in the same direction forever. And then we also have line N, which this one is already named. It's already named and it's a lowercase letter, so I can call it line N. Now, if I'm going to use the capital letter, if I'm going to use the capital letter from the points, I could call it line XY and just spell out the word line. So this way I know I'm talking about the whole line. Because if I just say XY, it could mean a segment, which we're not talking about a segment. We're talking about the infinite directions and both sides thing. Right? So if I zoom out, it goes in forever in both directions. And then with lines, you have a couple of things that can happen with points. So if they are on the same line, we call that collinear. So again, collinear, co meaning the same and linear meaning line. So it just means on the same line or with the same line. So X, Y, and Z in this case would be non-collinear. So they are not on the same line. So points that do not lie on the same line. Now this must be at least 3 points because, well, if you only have 2 points, they're always going to be collinear. If you have 3, there's a chance that they're not going to be collinear. So, you could have Z on the line right here or anywhere on the line really. But in that case, they would be collinear. But since they're not all lined up, they are not collinear. All right, plane. So a plane is a flat surface made up of points. So again, think of it like a whiteboard. I think I even have one actually. You know what? I'm gonna go, I think it's right there. I can see it. Okay. I was wrong. I don't have one. But I thought I had a little whiteboard somewhere. Like it's like the size of a piece of paper and you can mark on it with the marker. But that's a good example of how you can describe a plane, is that it's just a flat surface made up of points and you would need at least 3 points to make up a plane. And again, it goes indefinitely, which indefinitely does not mean infinite, but it can mean infinite. Again, the example I used before was, a guy was arrested. We don't know all the crimes he's done, so he's in jail now indefinitely. He could be let out like immediately, or he can be let out in a few days, or even never. Although that's usually not the way jail works. Usually, if it's longer than a couple of, like a month or so, then it usually ends up prison time. But anyway, yeah. I guess you would just say, arrested or detained or something. Anyway, name a plane by any non-3 collinear points on the plane, or the uppercase script letter. So plane P, which is not marked, and then you also have the points that make it up, plane KJL. Hello? Well, for this one here, you're going to have to actually go to the Zoom. And if you look at the packet, the summer school packet, it says you are required to attend every day through Zoom.